Very good morning, student. I am Asim Kumar Mandal as a teacher, SANDIPANI Higher Secondary School, RAJODA. We are taking chapter number 1, class 12 physics, electric field and electric charge under the unit number first. In the last and the previous videos, we getting some questions related to torque, axial position, coaxial position, work done and so on. In the given question, drive the expression. What is the demand of the question? Drive the expression for the amount of work done. Student, just focus on the word amount of work done in rotating a dipole in a uniform electric field. What is the demand of question? Drive a derivation to determine total work done in rotating a dipole in a uniform electric field. Student, firstly we introduce what is the mean of the uniform electric field. Uniform electric field, that means a field in which in any point the intensity of electric field will be constant, just like a board. At any point the intensity of whiteness is constant, so its parts are known as uniform. In the case of the uniform electric field represented by parallel lines. Uniform electric field represented by parallel lines. The direction of uniform electric field represented by arrow, maybe upward direction, maybe downward direction. So we taking vector E. What is the mean of the vector E, student? Vector E, that means intensity of electric field. I hope you understand. Vector E, that means intensity of electric field. Uniform electric field defined by the picture. Now time for electric dipole. What is the mean of the electric dipole? Electric dipole, that means a system. That means a system which consists to unlike charges. That means a minus q and a plus q. And the distance between them is very small, which is known as the effective length of electric dipole. I repeat my sentence. Electric dipole, that means a system which consists two different charges with very small distance, which is known as the effective length of electric dipole will be equal of 2L. So student, let we consider AB is a electric dipole. I hope you getting proper meaning of the electric dipole. AB is a electric dipole. O is a center of electric dipole which make angle with the uniform electric field will be equal of theta. Now force. What is the mean of the force? Here force represented known as torque. What is the mean of the torque? In the case of the bicycle, when we moving with the bicycle, two forces, okay, on the handle two forces are applied. Both forces are equal, but the directions are different. In this situation force are known as the torque. Okay, force F1 and F2 both are equals, so denoted by capital F. Force will be equal. What is the proper definition of intensity of electric field? E equal to F upon में charge, such that force will be equal of E into Q. So F equal to EQ. Where is the charge? That means a plus, so plus QE, and here F equal to minus QE. Student, I hope you are getting the proper meaning of each and every point. Let we consider uniform electric field. Uniform electric field, vector E. AB is a electric dipole which consists 2 points, capital A and capital B. On the point capital A consists positive charge, on the point B consists negative charge, and the distance between A and B will be equal of electric length of electric dipole represented by 2L. Now time for derivation. We denote a perpendicular, we taking the perpendicular from the point A and the point B. Both are perpendicular, so angle will be equal of 90 degree. Angle will be equal of 90 degree. Now we know the property of alternate angle. What is the meaning of the alternate angle? Z, the symbol of the Z, alternate angle. O, then B, then let we consider point N, point O. There is the another property like a alternate angle, so theta will be equal of theta. I hope you getting the proper meaning of alternate angle. Now we draw triangle A, N and B. Here angle on B. Now in front of 90 degree are known as hypotenuse and the front of angle are known as perpendicular. Remaining side will be equal of base. I think you getting the hypotenuse, perpendicular and base. Now time for derivation. Again I recall the diagram. Let me consider a uniform electric field vector E which consists any electric dipole AB. A consists positive charge and B consists negative charge. The effective length of electric dipole will be equal of 2L. Let me consider theta is an angle which made by the electric dipole due to uniform electric field vector E. And the length of electric dipole will be equal of 2L. We draw again a diagram for the help of the derivation. Now time of derivation. Now time for derivation, students. Derivation. I hope you know work done. What is the meaning of the work done? Work done, that means a force into displacement. What is the meaning of the force? Force, that means a torque. So we have to find out firstly torque. So we will start with the definition of the torque. By definition of torque, my dear student, what is the proper definition of the torque? Torque will be equal of any one force. What is the meaning of the any one force? Here how many forces are there? Two forces, upward direction and downward direction. We choose any one force between the these and these. What is the proper definition of torque? Any one force into perpendicular distance. Now representation of torque represented by tau, that is a symbol of tau. Any one force, that means a capital F. What is the mean of perpendicular distance according to the diagram in the triangle ABN? What is perpendicular distance? AN. So we taking AN. I hope student you getting the proper part of part of AN. Torque will be equal of any one force into perpendicular distance. Any one force, that means a force, perpendicular distance, that means a AN. So now torque equal to any one force, that means a maybe positive, maybe negative, depends on student, depends on user. We taking positive QE into AN, but in form of magnitude. I used statement in form of magnitude. What is the mean of the magnitude? Magnitude, that means doesn't include positive and negative sign in front of charge. So torque will be equal QE into AN. I repeat, into, not a cross product, into. I hope student you getting. Now in triangle ABN, take here hypotenuse is 2L, and we have to find AN. Hypotenuse and perpendicular, that means we used sin theta. Sin theta equal to perpendicular upon में hypotenuse. Perpendicular, that means AN. Hypotenuse, that means AB. AN unknown quantity, but AB will be equal of 2L, such that by the cross multiply AN will be equal of 2L sin theta. So by the use of value of AN, we can return QE into 2L sin theta. We used Q into 2L sin theta. What is the value of the Q into 2L? Q into 2L will be equal of P. What is the mean of the P? P, that means electric dipole moment. By the definition of the electric dipole moment, we can write Q into 2L will be equal of P, such that students, torque E P sin theta. So tau will be equal of P E sin theta. In the vector form, if you want vector form, in vector form you can write torque will be equal of P cross E, just because of the sin theta replaced by the cross product, but in the cos theta replaced by the dot product. So vector torque equal to vector P into vector E. I hope student you getting the meaning of the torque. Now student, time to calculate work done. Now work done in rotating the dipole through an angle d theta. Let me consider a small angle d theta. So what is the proper definition of the work done? Work done will be equal of force into displacement. So work done represented by W, but in the case of the d theta we use d theta, so work done will be small represented by dw. Theta, that means W, d theta, that means dw. Force, here force are known as torque. Force will be equal of torque, so tau into d theta. What is the mean of the tau? Tau will be equal of Pe sin theta and d theta, equation number 2. Now we have to calculate total work done. Total work done from 0 degree to theta. What is the mean of total in case of the physics? That means simply taking integration in both sides. Integration dw Pe sin theta d theta. What is the representation of integration? Here dw, that means a limit in form of w. Dx, that means a limit in the form of x. Dy, limit in the form of the dy. Dw, the limit in the form of dw. D theta, that means a limit in the form of theta. What is the initial value of work done? At the initial time, work done will be equal of 0. In the final time will be equal of W. Initial time angle will be equal of 0 and finally will be equal of theta. Student, integration dx equal to x, integration dy equal to y. So integration dw will be equal of W, limit 0 to W. Integration d theta, that means we consist only values in the form of theta. Another values take outside of integration. Integration sin theta. What is the value of the integration sin theta? Will be equal of minus cos theta. Okay? Two types of substitutions are there. We are taking the simple method. Okay, when limit will be changed, that means upper limit convert into lower limit and lower limit convert into the form of upper limit, the sign will be changed. So minus cos theta will be converted into plus cos theta. Now How to solve limit? Limit, that means upper limit minus lower limit. Integration dw, that means we put the limit in the form of, in the place of w. dw, that means place in w. So upper limit minus lower limit, pe. In the case of d theta, we put in the place of theta. Upper limit cos 0 minus cos theta. So w minus 0 will be equal of w equal to pe. चलिए, what is the standard value of the cos 0? Cos 0, that means 0 1 0, sin 0 0, cos 0 1. So cos 0, what is the standard value of the cos 0? Equal to 1, that means 1 minus cos theta. I hope student you getting the proper solution for derive the expression for the amount of work done in rotating a dipole in a uniform electric field. In the case of the work done, we have to find out, firstly we have to find out work done, we have to find out torque, because work done will be equal of force into displacement, force stored in the form of torque. So firstly we have value of torque, then put the value of torque in work done equal to force into displacement, then finally we getting the total work done. I hope student question is finished. So thank you so much.